Welcome to Lesson 5. Why use hydraulic power? So when we ended our Lesson 4, the introduction for hydraulic systems, I basically said that if you're in engineering, if you're an engineer, or you're studying and you're getting to know all the ins and outs of engineering, you're probably asking yourself a question: why are we doing this? Why are we converting this energy a couple of times? This is a lot of parts that are basically inefficient, and we're losing some energy. So today we're going to discuss why we do this. Why do we use hydraulic power? So to better explain this and to tell you why you should use hydraulic power in certain situations, we're going to use an example task. So this task is pretty simple, and it's basically we need to lift a load by a distance of 500 millimeters, which is half a meter. And we want that lift that's lifting our weight to have speed control. So if you want to lift it slow, you can lift it slower. If you want to lift it fast, you can lift it faster. And here we have 4 solutions basically for this task. And the first solution is an electrical solenoid. So electrical solenoids, they have linear motion, so it's not going to be a problem. You don't have to convert rotary to linear motion. But the problem with electrical solenoids is that they don't travel 500 millimeters. They're usually limited to about 100 millimeters. So electrical solenoids are a no-go for this task. Okay, and in B, we have a DC motor, direct current motor. DC motors are good in terms of speed control. You can make a DC motor run at whatever RPM you want. You just have to tweak some things around it. And one minor problem is that DC motor has an output shaft that spins, right? It has a rotary motion, so you need some kind of device that's gonna convert that rotary motion to linear motion, because we need to lift a load in linear motion. And that's also not a problem because we have screw jacks and worm screws and all these different devices that are pretty efficient that convert rotary motion to linear. The problem with DC motors is maintenance. There's a lot of maintenance with DC motors. It's expensive. You have to, every now and then, you have to replace the brushes in the motor and the commutator. So a DC motor for now is a no-go. So we're gonna just put a red line here. Okay, and we have come to the AC motor. So we can lift this weight by using an AC motor, which is virtually maintenance-free. But the AC motor has a little problem because it's essentially a fixed speed device. And the speed of an AC motor is determined by number of poles and the supply frequency of electricity, right? So if we need to have speed control for this lift, then AC motors are also a no-go. So we come to the hydraulic system, and here, before I show the hydraulic system, I would like to show the electric system with an electric motor, an AC motor. So as you can see, electric motor is spinning. The output shaft is spinning, and it's connected to a screw jack, which converts this rotary motion to linear motion. Okay, and I'm going to show a picture of a screw jack right now, so you can see. And also we have to have 2 switches, the top limit switch and a bottom limit switch. So when our lift comes to a certain point, the motor stops working. So this is the electrical system. And let's get to the hydraulic system.